In this video, I want to derive the law of cosines for you. So I'm going to take any triangle, start with any triangle, and what I'm going to do is I'm going to place the triangle on the coordinate system here so that one of the angles is in standard position. It doesn't matter which one, just pick one. So one of the angles is going to use, it'll be at the origin here. One of the sides will be the positive x-axis, and then the other side of the angle is wherever it ends up, right? And then there. So let's say it's angle A that was put at the origin, and let's put angle B up here and angle C over there. So this is side length A, this is side length B down here, and this is side length C over there. And what I want now is coordinates. I'm gonna use this length of this side over here to come up with an equation. I'm going to get this length two different ways. Okay. So here we go. I'm going to put coordinates. Well, I mean, maybe it's obvious that the coordinates of point A here are 0, 0. And the coordinates of this point, well, certainly it's on the x-axis, so the y-coordinate is 0. So this point right here, coordinates are 0 on the y, and the x-coordinate is this length here, which is B. Right? Now, does that look like a B? Now I want the coordinates of this point. Now the coordinates of that point, there's an x-coordinate and a y-coordinate. So if I drop a perpendicular, and maybe you've seen this happen before, we drop a perpendicular down to the x-axis here. Now I happen to draw this pretty close to a 45-degree angle, but it's just any random angle, whatever it happens to be. The point is, I can find the x-coordinate and the y-coordinate of that point by looking at this right triangle. Because the x-coordinate is going to be the hypotenuse times the cosine of that angle. So the coordinates here up at this point, it's going to be c times the cosine of the angle A. And then the y-coordinate, that's the opposite side, so it's going to be c times the sine of A. Okay. And now what I'm going to do is I'm going to look at the length of this side here, which has an A on it, and I'm going to calculate it. Well, I know it's length A, so actually I'm going to do the length squared. So A squared is equal to, and actually I guess I'm doing Pythagorean Theorem here. So A squared is going to be this side squared plus that side squared. Well, this side squared is just the y-coordinate right here. So this is c times sine A squared. And then the side down on the bottom here, well, that's, actually think of it as the x-coordinate here, or the x-coordinate here minus x, so x-coordinate, this x-coordinate minus that x-coordinate, right? So that's b minus c cos A. And really the y value was the difference in the coordinates too, right? This one minus that one. This one minus that one. It doesn't matter which order that I subtract them in because I'm squaring. I mean, technically subtraction, it does matter which direction, but once you square it, it's going to end up positive anyway. So whether you do b minus c cos A or c cos A minus b, it doesn't really matter because you're going to square it. All right, so there's the Pythagorean theorem on that triangle right there. But now that gives me a relationship between side lengths A, side length B, side length C, and angle A, right? So here we go. Let's see if we can simplify this a little. I'm going to leave that there. This is c squared sine squared A, and I'm going to FOIL this out. So I've got b squared minus 2bc cos A, and then a plus c squared cos squared A. Okay. So with that being done now, I'm going to gather some like terms. Let's see, I've got a squared equals, I'm going to put the b squared next, which is kind of alphabetical here. I see a c squared sine squared A. I also see a plus c squared cos squared A. And then what's left is a minus 2bc cos A. Right? Now, in here, these two things that have a c squared in it, factor it out. That's a c squared times sine squared A plus cosine squared A. But the sine squared A plus cosine squared A is equal to 1. So all those two terms here in the middle just turn into c squared times 1. So what I have is a squared equals b squared plus c squared minus 2bc cosine of a. That is what's called the law of cosines. What it does is it relates all three side lengths with one angle, right? A, B, C, and angle A. It's B and C in there. And notice that the side that's over here by itself, a squared, is across from the angle that's used. So there's a and there's cosine a, and everything else on the right-hand side is in terms of the other two sides, B and C. Right. Now, I should point out that I got this relationship in terms of angle A because angle A was the one I chose to put in standard position here. If I had chosen B, then I would have ended up with a similar relationship, only with angle B and side B over there. It would be that b squared equals a squared plus c squared minus 2ac cosine b. It doesn't matter which angle we put it in standard position, we'd get the relationship. Or likewise, I could have c squared equals a squared plus b squared minus 2ac cosine c. Wait a minute, where am I? Sorry, I'm not paying attention. I'm thinking about something else. This is c squared, a and b. It's got to be a and b cosine c. Right? Any one of these three is what I would call the law of cosines. Relates all three sides to one angle. Right? And the angle and the opposite side are on opposite sides of the equation here. All right. Notice this feels a lot, to me, it feels a lot like Pythagorean Theorem. I mean, this one right here, c squared equals a squared plus b squared, and then this extra stuff. Notice, so I'm going to look at this last one here. If angle C equals 90 degrees, and the cosine of C, cosine of 90 degrees is equal to, I'm thinking cosine of 90 degrees, I'm picturing this 90-degree angle right here. Cosine is the x-coordinate divided by r. Well, the x-coordinate is 0 if I'm on the y-axis there, so cosine of 90 degrees is 0. And so this turns out to be the Pythagorean theorem. C squared equals a squared plus b squared. Right? And the picture that I see here is like this. If that's a right angle, if angle C here is a right angle, this is a and this is b, right? Then a squared plus b squared is c squared. If, however, the angle C is smaller than 90 degrees, keep this same a, sorry, that's b, keep the same length b and this a, right? So you make this angle a little smaller, then this hypotenuse just got shrunk down some. So c squared is now a squared plus b squared minus a little bit because it's not as long as it used to be, right? So this cosine of angle C here, cosine of angle C is going to be a positive number in the first quadrant, right? And so you're subtracting something. On the other hand, if angle C got bigger than 90 degrees, keep B the same as it was there, keep A the same as it was, that side length C now, there's angle C, there's side length C, that just got longer than it would have been. It got stretched. How does that work here? Well, if C is in the second quadrant, remember the cosine of a second quadrant angle, x over r, that x-coordinate is negative. So cosine is negative, and I'm subtracting this negative, which is actually going to be adding something on. Right? So the law of cosines is a generalization of the Pythagorean theorem. If the angle here is 90 degrees, then you're talking Pythagorean theorem. If it's not 90 degrees, then it's compensating. That c squared is not a squared plus b squared. It's either a little bit smaller or it's a little bit bigger, and this takes that into account. Okay. That's the law of cosines. We'll come back in another video and show some examples of how you use it.